Hi guys, Miss Morris here, and I'm going to walk you through some congruent triangle proofs. So let's take a look at our given information. I've already marked my diagram with the given information. Angle 1 is congruent to angle 2, so you go ahead and mark these angles congruent. And ray CB bisects angle ACD. ACD is here. I know by definition of the word bisect that it divides an angle into two congruent angles, so I've marked it there. So make sure you're marking your diagram. Look at what we're trying to prove. We're trying to prove these triangles are congruent, ABC and triangle DBC. So these are congruent. So we're looking for our 5 ways: side, 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 angle, 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 side, or hypotenuse leg, which is only for right triangles. Okay, so what I've done is written the given information already in step 1, and we've marked the diagram. But we have never said the conclusion that we came up with for this word bisect. What we need to do is list our congruent angles next. So angle ACB is congruent to angle DCB. And then we need to justify why we wrote this statement. So we wrote this because of our given information right here. So this is always your clue. We will write the definition of bisect. And we need to determine if it's segment or angles. This one is angles. So an angle bisector will divide an angle into two congruent, you could say parts, or you could say what we're talking about, angles. Okay, so everything we've marked on the diagram is listed here. We really need one more congruent part, because so far we have 2 angles that are congruent. So we have the possibility of doing angle side angle or angle angle side. So I'm looking to see which side I can prove to be congruent. And I notice that they share side BC. So I'm going to go ahead and mark that and list it in my proof. BC is congruent to itself. I'm talking about BC is a segment in the top triangle and BC is a segment in the bottom triangle. Anytime something is congruent to itself, it is the reflexive property. And I have everything I need. I have an angle listed here. I have a side listed here. I'll put it to the side here. And I have an angle here. So we just need to make sure we look at the triangle and do the correct order. Angle, side, angle. The side is included. So I know that the triangles are congruent by angle, side, angle. So we're finished. You always finish your proof with your original proof statement and then make sure that you've backed it up. Okay, let's look at example 2. All right, some given information. It looks like it's already marked for us. N is the midpoint of LW, so that's marked. N is the midpoint of SK. So that's where we begin with our given information. Okay, that's all that's given to us, and we've listed it. So now let's take that given information and draw a conclusion. So if N is the midpoint of LW, that means that we have 2 congruent segments. LN is congruent to WN. Okay, there's also some more information. I'm going to hold off on this reason. We also have N as the midpoint of SK. So I'm going to go ahead and list out these congruent segments. So SN is congruent to KN. Okay, so where did we come up with this information? We used the given information that says midpoint. So you're going to basically write the definition of a midpoint. A midpoint divides a segment into two congruent segments. And guess what? We did it twice, so I'm just going to use these markings to indicate that the reasons for 2 and 3 are the same, midpoint and midpoint. Okay, so we have two segments. If you look at just one of the triangles, we have two segments. We need either a third segment or an angle. Well, it's already marked on the diagram for you. So it looks like an angle. LNS is congruent to angle WNK. And other than it being marked in the diagram, what type of angles are these? These are vertical angles, and vertical angles, whether they are marked on the diagram or not, are always congruent. Okay, and I think that is all we need to prove the triangle's congruent. We are going to prove the triangle's congruent by side, angle, side. The angle is included. It's between the two sides. So my very last step is that the triangles are congruent by side, angle, side. Make sure that your congruent statement perfectly matches what's up in the proof statement. And then you're done. Okay, example 3. Let's mark our diagram with our given information and start with step 1. BC is congruent to DA, so mark those segments. And segment AC bisects angle BCD. So the angle's been bisected. So I'm going to go ahead and mark congruent parts. Okay, so you list your given information, your reasons it was given to you. Okay, now we want to take bisect and write the conclusion that we come to. So angle BCA is congruent to angle DCA. Why? Because of this word bisect. And we are doing an angle again. So an angle bisector divides an angle into two congruent parts or two congruent angles. Okay, so we're trying to prove the triangle's congruent. We want to come up with a plan here. Right now we have a side and an angle. So we need another angle or another side. Looks like they share side AC. So we can use the reflexive property to show congruence. AC is congruent to CA by the reflexive property. Now I wrote AC and CA because I'm looking up here at my congruent statement. AC of one triangle corresponds to CA of the other triangle. So just make sure you're matching the congruent statement. That is all I need to prove. Now wait a second, we've got side, angle, side, And then we've got angle side side. So this proof cannot be done. The triangles are not congruent.